Hello students, welcome to CREATA classes. I am Gurmeet Singh and in this lecture we will take down exercise 7.2, question number 6 to question number 10. Check out the link to all other lectures in the description and also do not forget to download the PDF of the concept and the formula list. The link is given in the description. We use the power of visualization to make you understand the concept in much easier way. That's our specialty. We believe in adding creativity to the learning. So without taking any further time, let's start exercise 7.2, question number 6. Here it is.
The question is, if 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find x and y. This question is talking about a parallelogram whose 4 vertices are given. Okay, these are the 4 vertices of a parallelogram. Let's give name to these 4 vertices as A, B, C and D. Here in this question we have to find the value of x and y. That is, we have to find the coordinate B and C. Y is missing in the coordinate B and x is missing in the coordinate C. So how we will approach this question? We will use the property of the parallelogram, that is, the diagonal of a parallelogram bisect each other. This is the property of the parallelogram, that is, the diagonals of the parallelogram bisect each other. So firstly, let's draw the diagonal, that is AC and BD. These are the two diagonals and these two diagonals are meeting at the point O. As per the property, AO will be equal to OC and OD will be equal to OB. That is, O is the midpoint of the diagonal AC and O is also the midpoint of the diagonal BD. Based on this property, we will try to solve this question. So firstly, let's take the diagonal AC. Here let's assume x1, y1 as the coordinate A and x2, y2 as the coordinate C. Here the point O is dividing this line segment into the ratio of 1:1. Okay, O is the midpoint of AC. So O is dividing this line segment into the ratio of 1:1. Means M1 is to M2 will be equal to 1:1. That is, M1 is 1 and M2 is also equal to 1. So let's apply the section formula. On applying the section formula, we got our x coordinate as x plus 1 upon 2 and we got our y coordinate as 4. Simply we have put the value and we have solved it. Okay, got it. Now let's move further to the next diagonal, that is the diagonal BD. Same fundamental we will apply. Here the point O is the midpoint of BD, that is M1 is to M2 will be equal to 1:1. That is, M1 is equal to 1 and M2 is also equal to 1. Let's apply the section formula. We got the x coordinate of point O as 7/2 and we got the y coordinate of point O as y plus 5/2. Okay, we got the two coordinates of point O. Let's equate both of these coordinates. So firstly, let's solve for x. We got 1 plus x upon 2 is equal to 7/2. On solving, we got x is equal to 6. Similarly, let's equate the y coordinate. On solving, we got y is equal to 3. Okay, we got value of x as 6 and we got y as 3. Okay, that is the answer of the question. So how we have approached this question? We have applied the section formula and we have applied the property of the parallelogram, that is, the diagonals of the parallelogram bisect each other. So based on these properties, we have solved the question. Got it? Let's move to the next question. The question is, find the coordinates of a point A where AB is the diameter of a circle whose center is 2, -3 and B is 1, 4. Here this question is talking about a circle whose diameter is given as AB. The coordinate of B is given as 1, 4 and we have to calculate the coordinate of point A. Let's assume the coordinate of point A as x, y. In the question, the center of the circle is also given as 2, -3. Let's assume the center point as C. Here AB is the diameter and C is the center. means the C is dividing the diameter AB into two equal parts, that is into the equal ratio. So we got AC is to CB is equal to 1:1. Here the point C is dividing this line segment AB, that is diameter of the circle, into two equal parts, that is 1:1. So we will apply our section formula. Let's apply the section formula. Firstly, we will take the x coordinate. So on putting the value, we got 2 is equal to x plus 1 upon 2. Here x is a variable. Let's find the value of x. On solving, we got x as 3 unit. Similarly, let's use the section formula in the y coordinate. We got -3 is equal to y plus 4 upon 2. On solving, we got the value of y as -10. We got x and y are the x and y coordinate of point A. So we got our coordinate of point A as 3, -10. This is the answer of the question. Okay, so how we have solved this question? We have applied the section formula and we have also applied the property of the circle, the basic property, that is center is dividing the diameter into the equal ratio, that is 1:1. So based on these simple properties, we have solved this question.
So we have done with question number 7. Let's move to question number 8. If A and P are -2, -2 and 2, -4 respectively, find the coordinates of P such that AP is equal to 3/7 AB and P lies on the line segment AB. So firstly, we will observe the question. In this question, the line segment AB is given. The coordinate of point A is -2, -2 and the coordinate of point B is 2, -4. And one more point is also given on this line segment AB, which is point B. And further, it is also given that AP is 3/7 of AB. And in the question, we have to find the coordinate of point P. Let's assume the coordinate of point P as x, y. This point P is basically dividing the line segment AB into certain ratio. Firstly, we will find that ratio, then we will apply the section formula. One hint is given, that is AP is equal to 3/7 AB. If you observe this 3/7, it basically means that we are having total 7 segment and the AP is having the 3 segment and the rest of the 4 segment is between the PB. So 3 segment at AP side and 4 segment at PB side, and AB is having total 7 segment. So 3/7 is basically denoting the ratio of AP is to PB as 3:4. So this is a general understanding what the ratio or what the 3/7 the fraction means. But we will not go by this philosophy. We will just try to solve in the mathematical term. Let's see. Here let's take AP is equal to 3/7 AB. We can rewrite this as 7 AP is equal to 3 times AB, and AB is basically composed of AP plus PB. On solving this equation, we can rewrite this as 4 AP is equal to 3 PB, which is basically AP upon PB is equal to 3/4, which basically is symbolizing the ratio of AP is to PB is 3:4. So we got M1 is to M2 as 3:4, M1 is 3 and M2 is 4. We also know x1, y1 as A coordinate and x2, y2 as B coordinate. We can use the section formula to solve this question. Let's apply the section formula for x coordinate. Let's put the value. On solving, we got x as -2/7. Similarly, we can put all the values in y coordinate formula. We got y coordinate as -20/7. So we got the coordinate of point P, x, y as -2/7, -20/7. That is the answer of the question number 8. Let's move to question number 9. Find the coordinates of the points which divides the line segment joining A -2, 2 and B 2, 8 into 4 equal parts. So let's observe the question. In this question, a line segment AB is given. The coordinate of point A is given as -2, 2 and the coordinate of point B is given as 2, 8. And this line segment is basically divided into total 4 parts. Let's assume the dividing point as C, D and E. The 4 line segment or the 4 parts are AC, CD, DE and EB. And in the question we have to find the coordinate of point C, D and E. If you observe, we are having various ratios in this line segment AB. We can say the ratio of AC is to CD is to DE is to EB is 1 is to 1 is to 1 is to 1. Or we can also say the ratio of AD is to DB is 2 is to 2, which is basically 1 is to 1. Or we can say the ratio of AC is to CB is 1 is to 3, or AE is to EB as 3 is to 1. So basically we are having various ratios in this line segment AB, as we are having 3 points in between A and B. We can take any of the line segment and we can take that ratio. So let's approach the question. Firstly, let's find the point D, which is the center point of line segment AB. Here, can we say AD is to DB is 2 is to 2 or 1 is to 1? Okay, 2 is to 2 is basically 1 is to 1. The point D is the midpoint of AB, so D is dividing the line segment into the ratio of 1 is to 1. Now we can find the coordinate of point D using the section formula. This is the midpoint, so we can use this formula as section formula. So we got x as x1 plus x2 upon 2. So we got the x coordinate as 0. Similarly, we can get the y coordinate as y1 plus y2 upon 2, that is 5. So we got the x coordinate of point D as 0 and the y coordinate of point D as 5. So basically the coordinate of point D is 0, 5. Let's move to point C. For calculating the coordinate of point C, let's take only the line segment AD. So can we say AC is to CD is 1 is to 1? Yes, we can say so. We have only taken the line segment AD. We know the coordinate of point A, we know the coordinate of point D, and point C is at 1 is to 1 ratio, that is the midpoint of AD. So we can apply the midpoint section formula. We know all the input. Let's find the x coordinate. On solving, we got x coordinate as -1. Similarly, we can also get the y coordinate. On putting the value, we got y coordinate as 7/2. So this is the coordinate of point C. Let's move to point E. Here we will take the line segment DB. So this is the line segment DB and E is the midpoint of DB. We are especially taking those line segment in which we are getting the ratio of 1 is to 1. We can take the complete line segment also in which the ratio will be 3 is to 1, but we are not doing so. The answer will be same, no doubt, but we are only taking the ratio of 1 is to 1 because that makes the solution much simpler. We can use the midpoint section formula, which is very simple as compared to the big formula. But we can use any of the ratio, the answer will not change. So the coordinate of point E, again we will use the section formula. The x coordinate will be 1 and the y coordinate will be 13 upon 2. Got it? So we have done with the question number 9. Let's move to question number 10. Find the area of rhombus if its vertices are 3, 0, 4, 5, -1, 4 and -2, -1 taken in order. So this is the question. Let's observe the question. In this question, a rhombus is given and the 4 coordinates of the vertices are given. So we got a rhombus ABCD. We have to find the area of rhombus. Area of rhombus is half into the product of the diagonals. So basically in this question we have to find the length of the diagonals. The diagonals are AC and BD. So the area of rhombus is equal to half into AC into BD. This question does not involve the section formula. This question involves the distance formula. So we know the distance formula we have done in the previous lecture. So let's find AC.
Let's assume this point as x1, y1 and this coordinate as x2, y2. Let's put the value. We got AC as root of 32, which is basically 4 root 2. Similarly, we can also calculate BD, that is the second diagonal. We know all the inputs. On putting the value, we got BD as root of 72, which is basically 6 root 2. We got both the diagonals. Now we can easily calculate the area of the rhombus, which is basically equal to half into product of diagonals, that is half into AC into BD. So let's put the inputs. We got area of rhombus as 24. That is the answer of the question. This question does not involve the section formula, but it is given in the exercise 7.2. No worries, we know the distance formula, so we can solve this question very easily. So students, we have done with the complete exercise 7.2. This is the complete series on coordinate geometry. The link to all other videos are given in the description. Check it out. Meet you in the next lecture, in which we will cover the area of the triangle. So bye for now. Have a great day. Bye bye.